Good afternoon, everybody. Welcome to Thursday afternoon, Chem 170, with your host, me, Dr. White. Excuse me. I've had a busy morning. Traffic was bad. I just got home about 20 minutes ago. Wow. But anyways, I'm all fired up. All right. First of all, as soon as we're done with today's lectures and lab, I will be sending out, a email to each of you with the password for test number one. And test number one, let me open it up so you can get to see what I'm doing. All right, thumbs up, people. Everybody see D2L on your screen? Anyone? Thank you. All right, now what you'll do is click on assignments and you can open it up or download it. And there's a password. At end of class today, maybe 5-10 minutes afterward, I will send out a password for this, open this file. And you should take about an hour, but don't tell anybody, take an hour and a half to actually do the test. And that's not part of that hour and a half for you to scan it or take a picture and upload it. I'm talking about just taking the test. Now, if you do not have a printer, what you should do is look at the test on your screen, and you can just on a piece of paper, write your answers. You do not have to rewrite the questions. You don't. And make sure you put your name on it. And either way, make sure if it's printed or you take on a piece of paper, make sure either with your cell phone or scanner, you make a PDF file, just like you've done the labs, and upload it here. The deadline is tomorrow, 11 a.m. Gives you plenty of time. Please don't cheat. As you'll see in the email I'll send out, I don't know if I put it in the email, but I'll tell you now, I have put things in there that tells me when a student has cheated, and unfortunately it works. So please don't. Alex asked just if she can write on the iPad. Yep. You want to write on that, and I'll get to Nana in a second. If you want to write it, save it, and upload it that way, like you did the labs, that's fine. Either way. Now, Nana asked, as soon as we open it, do we have an hour to complete it? No. Say you downloaded it and opened it, so download it, but something comes up and you got to make dinner for your kids or whatever. Once you start actually reading the first question to take a test, like if you were in the classroom, that's when the clock starts. And you shouldn't, honestly, if you've done the practice problems and studied a little, it shouldn't take you more than 35 minutes. When we do this face-to-face, students usually are done by the slowest ones within 45 minutes. Most classes done within about 35 minutes. And any other questions about test number one? No, Jordan, there's no real clock. I am going on the honor system. And honestly, if you don't know what you're doing, I can give you 5 hours and you still won't do good. But this way, it takes the stress of the clock off your shoulders. because an hour and a half once you start is more than enough. Okay? Any other questions? Thank you. My tests are designed, you show me what you've learned, be honest about it, because if you're not, I will do what's in my syllabus. Speaking about that, make sure everybody, I'll extend the deadline. If you have not submitted the signature sheet right here, and some of you haven't, make sure you do it by Monday. And probably tomorrow or Saturday, I'll send out a reminder email for those who haven't. Oh, we almost got a full house today. Now, another thing, and it will be in the email, sometimes you're taking a test and you got a question. And as you know, in my world, there's no such thing as a dumb question. And that pertains when you're taking a test. Well, if we were face to face in a classroom, what I do is ask you, let's go out in the hallway because I need to hear you better. Even with my hearing aids, I'm wearing them because I have amplified speakers up there. But if you have a question, email me it. I'll try and answer it. I'm not going to give you the answers to the problems, but if you're not sure about a question, hopefully I've done my job right. And I've done these types of tests many times before, and I think I have. But if you have a question, email me tonight and tomorrow. Once I send out the password, about every 2 hours until maybe 10 o'clock tonight, I will check my email. And then the first thing in the morning tomorrow, I'll check it till I got to go out and do some stuff in the morning, but I'll try and check it until 9 or so. Now, Boris asked, do you have to finish it in one setting? Well, if something comes up and you got to take care of it, the answer is no. We're face to face, yes. But I will ask on the honor. And plus, I also know, because the things I put in my, you should not be looking at your notes. You should not be going on the internet. And unfortunately, I have things in there that tell me if people do. I'm not going to tell you what they are, but if you have to spend 20 minutes or 30 and something comes up and you come back, I'll allow that. Okay, any other questions? All right, let's continue on. Today, I'll be continuing with alcohols, and then we'll get into thiols, and let's see if we'll get into ethers today, maybe. I'd rather be a little ahead of things, and then we'll do the lab. And today's lab is real quick, and so I may even let you out a little earlier. So if you want, you can get started on the test. All right, before I do that, I better do a public service. And what's that public service? We're talking about alcohols. And remember, alcohols and this material will not be on test number 1, but will be on 2. Now, what I'm going to talk about right now, I will not put on a test, but it's something I think I should tell you about. And that is, there's a molecule, and this will never be on a test. Let me do it this way. It's not what I want. That's what I want. Notice here and here, and you don't have to write this down. They're hydroxyl group on carbons. This is called a diol in general, but this has a special common name called bisphenol A. As a trade name. And the bis means two. See one there. And this is the A part. Different things there is a B and C. But this is bisphenol A, also known as, you might have heard, BPA. Now, BPA is an interesting molecule. It's used to make polymers and it's used to make coatings. And when they make something I haven't told you about, if you react two things together, A plus B, to make C, it doesn't always go 100%. And sometimes you have some A and B left over. And if you don't do a good job purifying C, what you made, in C, there's going to be A and B. Well, that turns out when they make certain plastics with BPA, bisphenol A, or certain coatings. Well, what's that mean? It means there's going to be some unreacted free BPA in those products. And turns out the human body, by touching things with BPA or ingesting it, can absorb it. And unfortunately, BPA is a, what's the term? Endocrine disruptor. Your body thinks it's a certain hormone and gets fooled by that. Now, if you're old, that doesn't matter by now, but if you're young, pregnant, that messes up your body to some extent. And I'm telling you this because of the dangers of BPA. Now, it turns out a number of years ago, someone did a study and was able to extrapolate that in about 90% of Americans have BPA in your body. Yeah, 90%. And Mother Nature never made BPA. So you're getting it from contamination. Where do you get contaminated from? One, it used to be used to make baby bottles. And an interesting story, a company you don't think about being socially responsible, or maybe you do, help eliminate BPA from many things, especially baby bottles. And that company was Walmart. And Walmart, after a lot of people complained, told their producers of baby bottles, they're one of the biggest purchasers of baby bottles in the United States, if not the world, we will not buy baby bottles with BPA in that. And because of that, the rest of the industry followed. And so now baby bottles are BPA free. Now, where will you find BPA? I'm not sure. It might have changed in the last year or two, but for many years, if you get a receipt that's a thermal printed receipt, like at a supermarket, or the receipts you get from a gas pump, they have a coating made from BPA. And you touch it, you're going to get BPA in you. And again, this might have changed in the last year or two, but I doubt it. And if you're pregnant or young, don't let kids touch that or eat it, really. Not that they should. And if you're pregnant, if you go to a supermarket or if you go to a gas station, you get a receipt, I'd wear a glove, rubber glove. That's just my own thing. And I thought I'd share that with you. All right. Yesterday I was talking about oxidation of alcohols. And I started on primary alcohols. And a primary alcohol, O in a bracket, means oxidation will produce aldehydes. And we'll learn later on about aldehydes. Again, primary alcohol oxidize. You lose the hydrogen here and hydrogen there, and you form a carbon oxygen double bond. And you can also write it this way, but this is the way carbonyl chemists write it. It's cooler, and I do. If you write it this way, I'll always mark it correct on a test, but this way is cooler. So we did a one or two. Let's do an example, or you'll do it. So I already did one yesterday. And O in a bracket means oxidation reagent. The like potassium permanganate, sodium dichromate, or potassium dichromate are few. And that's what that means. And I'm using that instead of making you memorize all the different oxidizing agents, because it makes your life just a little easier. Your turn. Give the organic product or products are the following. One thing I should point out, two of you, I think, didn't hand in the lab on that was due on Monday. Please get it in. If you go to D2L, you'll see those of you who did hand it in. This morning, I did upload your lab scores. And as always, if you're curious, why did I lose a point? Always feel free to ask. There's no such thing as a dumb question in my class. All right, I launched the poll too early. Oops. And now try taking a poll again. Now, if we were face to face, I would be giving you a test right now. And that's where I can get away with this online by having you on the honor system take it at home. All right, looks like everybody's finished, so I'm going to get to work. All right, how do you do this? Well, you look at a molecule and you look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen should get your attention like that. Oh, look, an oxygen right here with a hydrogen. And since we're oxidizing it, I'll write it this way. It's a primary alcohol. And that's how you say primary alcohol, shorthand. And when you oxidize it, lose a hydrogen there, and you form a carbon-oxygen double bond. And what's my R group? This. Here's the carbon with the hydroxyl group, which becomes this carbon double bond with oxygen. Now, another way of thinking is, do you break carbon-carbon single bonds? No. I start with 4 plus 1, 5. I better end up with 4 plus 1, 5. This carbon right here is this carbon right here. It has double bonds to oxygen, hydrogen, and I know there are 4 bonds to carbon. And I'm done. And I've made that aldehyde. Now, yesterday I went through, I think you did one before. So let's go to something else using this reaction. And as I mentioned for test 1, there'll be one synthesis problem. Syntheses give the starting materials for something. Now, on test 2, I'll probably have 3. Any more would be cruel and unusual punishment, which is still outlawed by the Supreme Court, I think. And the question is, what do I oxidize to make that compound? And it's your turn. One question mark, one product, starting material, more than one, I'll be nice. And put 2. I don't think I have any reactions I've ever done more than 2. So it's your turn. And if we were in a class, I'd tell you, and I can tell you now too, Please be patient. I try and give everybody a chance to finish. And if you're done, don't forget to vote in the poll, please. All right, I think everybody's done, so I better get to work. Now, how do you do these problems? You look at the product and you say, what's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? Ooh, an oxygen. Double bond to carbon with a hydrogen and carbons. This is an aldehyde, and we'll learn later on about aldehydes. And how do you make an aldehyde? By oxidation. That's oxidation. You start with a primary alcohol. And if we look at this, here's this carbon double bond to oxygen, and everything attached to it is my R group. Another way is, do you break carbon-carbon single bonds? No. So you end up with 6 carbons, 4 plus 2. You better start with 6 carbons, 4 plus 2. The methyl groups are still there. This carbon at the end is this carbon, which is this carbon. So that tells me that needs to have this. And now I know there are 4 bonds to carbon, and I can put in my hydrogens. And that's how you do a synthesis with oxidation of a primary alcohol. And let's move on, unless there are any questions. Remember, it's always true in my class, there's no such thing as a dumb question. Now, if you have a secondary alcohol and you oxidize it, you'll get what's called a ketone. And we'll learn about ketones. And let me show you another nicer way of writing this. Now, if I were to do this slides over, I do all my diagrams by hand because the tablet I have helps. All right, now here we have this carbon, which is has a hydroxyl group. That's a secondary alcohol. And when you oxidize, it's the same type of reaction we do with primary. You lose this hydrogen, this one, and form a carbon oxygen double bond. What's attached to this carbon stays there. Now, if you notice, I have R and R prime, and that's just like X and Y in math. Those can be the same or different. And that's what this shows. This could have the same type of carbons as here, or they can be different. Now I can write an alcohol this way, which I sometimes do, or this way. And these are both the same molecule. I'm just making it, writing it in such a way that's easier to see the reaction. If I oxidize this, what do we have? This reaction. This is my secondary alcohol. I'll lose this hydrogen and this hydrogen, form a carbon-oxygen double bond. Now, what was attached to this carbon? R and R prime will still be attached. CH3, CH2, CH3. Now, if you looked at this structure, same thing, R prime, doesn't matter which one you call R and R prime. And when you oxidize it, you lose this on this carbon, you form a carbon oxygen bond, double bond. What was attached to it? And this carbon has both a methyl and ethyl group attached to it. This carbon has methyl and ethyl, so they're the same. Now, one of the exciting parts of secondary alcohol oxidation, in a primary, you can have a primary alcohol in a ring. But you can have a secondary alcohol in a ring. And if you oxidize it, you don't show it, but remember right here, there's a hydrogen. Because there's 4 bonds to carbon, 1, 2, 3, 4 minus 3 hydrogens there, but you don't show it. But this is a secondary alcohol. And when you oxidize it, you lose this hydrogen, this one, and form a carbon oxygen double bond. Now in a ring, R and R prime are connected together right there and there. Doesn't matter what you call R and R prime. So I'm still going to have the ring, and the carbon right here that has the hydroxyl group on it will be this carbon. And how do we show that? Like this. And this is called a ketone. And Dr. White loves aldehydes and ketones. So does Mother Nature. So same thing on a ring. You lose a hydrogen from the ring, oxygen from the hydroxyl group, form a carbon-oxygen double bond. And it's your turn. Give the product or products organic for that reaction. Oh, I should have mentioned earlier, and after the break, I'll mention it. If anybody has any questions about anything that might be on test number 1, after our first break, I'll take them. And you can ask any questions you have about any material on test number 1 in case you want to. Now, one thing I neglect to do, and I'll show you when I do the problem. All right, I think everybody's done. Let me show what I should have done earlier. If we look at this carbon, what's different? Hydroxyl group on a carbon. Now, you don't see the hydrogen there, but there's one there. If we look at this carbon, it's bond to carbons here and here, which are bond to other things, and that's our R group and R prime. And it doesn't matter which. You can say, and it doesn't matter how you parse it. This is my R. This is my R prime, or you can do it differently, but it comes out the same. And what happens when you oxidize a secondary alcohol, two R groups on the carbon with the hydroxyl, there's this hydrogen and this hydrogen. What's attached to that carbon is still attached. And let me do something quick, because this preference, as I normally do it, I'll make that R prime. Doesn't really make a difference, but I already wrote it this way here. So you form a carbon-oxygen double bond. Now, do you break carbon-carbon single bonds? No. So really look at this and you say a ring with a methyl group. I'm going to end up with a ring, six-membered ring methyl group. Which carbon had the hydroxyl group? That's this one. That will be the carbon double bond to oxygen. And that's how you do it. And here's one more for you to try. What would be the starting material that I oxidized to make that compound? Oh, excuse me. I'm looking at the screen. I didn't realize, I should have. I've got two Hannahs in here. All right, I think everybody's just about done. I'll give you another couple of seconds. Or did I forget to do this? I think I forgot to launch it. I'll do it again. If you already voted, vote it again. Be easier if you turn on your webcams for Dr. White. All right, looks like everybody's done. Let me get to work. So the question is, what's different when you're trying to figure out what do I start with an oxidize? That's what O in brackets means, oxidize, to make this compound. What's different? What's not carbon? What's not hydrogen? And oxygen. And it's double bond to carbon. Then on that carbon, I have carbons here. I'll call R prime. Carbons here. I'll call R. And this is a ketone. And what do we oxidize? A secondary alcohol. I can say this is R prime. In this case, they're the same. That's R. So I have this carbon becomes this carbon, which I'll write. And then what's my R and R prime? Methyl and methyl. And if you oxidize this to propanol isopropyl alcohol, you'll get this molecule, which you'll learn has the common name, acetone. And one of the main uses is nail polish remover. All right. Let's talk about alcohols with more than one hydroxyl group. And I thought you'd like to learn about that. When it has two hydroxyl groups or alcohols, we call that a glycol. And I'm turning the switch, we'll just be on test, to the off position. And probably one of the most important glycols is this. This is called ethylene glycol. It's a common name, not IUPAC, but it's used in our society. And where do you find ethylene glycol? You mix this with water, and we call it antifreeze. Remember, I talked about the colligative effect. There are two. One, you have the melting point lowering, and also the boiling point, which I didn't talk about then, when you have a colligative effect is higher. And if you think about it, if you had water in your radiator, in the winter it would freeze when it got real cold, and not even that cold. And the summer, like today, it could boil and you'd have vapor lock. Both are not good for your engine or your radiator. So somehow someone in the past found out that if you mix ethylene glycol with water, that's the perfect fluid for a radiator of a car. Now, next one, glycerin, has three alcohols in the same molecule. And it has this structure. Again, switches off. And glycerin is a common name, not the IUPAC. And this your body makes when you break down a fat or oil. Also, I worked for a company that made glycerin. I'll talk more about it. And we sold it places like cosmetic companies. And another thing that it's used for is it's one of the molecules for humectant. Now, humectant is something that keeps water in something by hydrogen bonding. Three alcohols, you'll have hydrogen bonding. And where would you see that? I don't know if they use glycerin, they might use another humectant, but for a number of years now, you can go to a supermarket or at a mall and buy cookies that are soft, just like when you got it out of the oven, but they've been out of the oven for a long time. And they put a humectant in there, alcohol, polyalcohol, to keep water in there, and that's how it stays soft. Now, sucrose, table sugar, has more than one alcohol. If you look at this molecule, and there's another form that shows you more, but immediately you see 1, 2, 3, 4, 5, 6. I'll move this over here. 7, 8. There are a lot of alcohols in table sugar, and that's a molecule with many alcohols in it. And the last one I want to talk about, give me a minute, how are we doing time-wise? Give me a minute or less, is PVA, which is polyvinyl alcohol, which has this structure. And switches off. And N here, this is repeated like boxcars in a train, and is on the order of 1 million. And all of you probably have PVA in your house. I don't have PVA in my house, Dr. Wright. Yes, you do. If you take polyvinyl alcohol and mix it with water, you have a white goopy stuff. Well, that's scientific goopy stuff. And it's called Elmer's glue, or the other white glues you keep wood together or paper together. And I'll talk later on when we get into polymers, how it keeps stuff stuck adhered together. If I look at the clock, oh, I went a whole minute over. Bad, Dr. White. Why don't you come back at 2:56 and we'll continue on. Let's take a break. Remember, after today's class and lab, I'll send out the password in an email to you, each one of you, so you can take test number 1 when you do today or whenever, but make sure you get it uploaded by 11 tomorrow. Break time. Time to get going. All right, let's continue. Now, next couple of slides, click, I'm turning the switch. Will this be on a test to the off position? Now, how many of you, and give me a thumbs up, and I'll go to this view so I can see more of you. How many of you have, and let me do one other thing I didn't do earlier. How many of you have ever heard of antioxidants? Give me a thumbs up if you heard the term antioxidant. I see some of you have. All right, now, what is an antioxidant? Well, that's a molecule that stops oxidation. But it turns out it's more sophisticated than that. It turns out air can oxidize things by reaction dealing with what's called radicals. And radicals are very, very reactive organic molecules. And I could do a whole 2-semester graduate level course on the chemistry of radicals. I'm not going to do that now for you. But anyways, air forms radicals that attack and break down certain molecules, organic molecules. And those are found in things like food, lubricating oil. Now, this is caused by radicals reacting with that. So how do you stop that? Use molecules that stop radicals from reacting. They stabilize them. And those are phenolic compounds. Phenolic means molecules that have phenol in them. And if you remember, in case you didn't, this is phenol. And also certain vegetables are chock loaded, like spinach or green leafy stuff, with antioxidants. They have phenolic compounds in them that Mother Nature makes. Well, it turns out years ago, what was one of the foods that went bad, really bad, when it is oxidized by oxidants, and air will do that, is potato chips. And there used to be, now they found a different way to protect them in the last 10 years, used to put and find certain antioxidants, BPA, BHA, and BHT in potato chips. And this is a safe compound, but they found a cheaper way to get that. And BHT is short for butylated hydroxytoluene, which has this structure. And one of the reasons Dr. White loves T-butyl groups is, here's a T-butyl group, here's one, notice you have a phenol, and down here you have a methyl group. And this is one of the molecules, when you have it's called hindered phenol, the hydroxyl group has these big groups around it, so it makes things hard to get to. That's called hindered. It's just a good antioxidant. Now, when I was in grad school and I'd be eating potato chips, which I really didn't eat, my mother would say, don't eat those, they aren't good for you. I'd say, Ma, they contain important antioxidants, which is healthy for me. She never bought that, and I really shouldn't have said that. Now, what I'm about to say, I don't know if it's true or not, but for a number of years now, certain people in the medical profession have said aging is called by oxidation, air oxidation, and other radicals that you form in your body. Is that true or not? Don't know, but that's why they push you should consume antioxidants. All right, new functional group time. Switch is sort of on, and this new functional group is called the thiol. And I have here thiol is a sulfur analog of alcohol. What does that mean? Well, let's take a look. This is an alcohol. If I replace the oxygen with a sulfur, it's like an alcohol, but instead of an oxygen, I have a sulfur. And IUPAC nomenclature, CHI means sulfur, but here you learn the ending for alcohols is OL, and someone decided at IUPAC, let's combine the two parts and call it a thiol. Now, before thiol, and back when I was almost, well, even after I got my PhD for a while, it used to be called mercaptan, which was another way of saying sulfur. But it's now for a number of years been called thiol, but I still sometimes will say the old name. Now, we won't cover any reactions or nomenclature of thiols, but it's similar to alcohols, except instead of using OL ending, use THIOL. I will not put on test anything to do with nomenclature of thiols. Now, what's important about thiols? They stink. What? They stink. And I mean, they stink. Whoa, they stink. Now, I'm going to skip to the next slide, 2 slides. What's something that's stinky? Skunk odor. If you have a skunk that's let loose on an animal or nearby where you are, you'll smell it. Now, someone, and I'm glad it wasn't me, analyzed that, the defensive weapon the spray a skunk uses, and found it was 45% this thiol and 25% this, and I believe the remainder is water. And that's stinky. Now, where else can you find thiols? Well, onions and garlic stink, or if you like to smell, and I like onions and garlic, the smell are due to thiols. Now, another important thiol, and this I'm turning the switch on, was a dial that could go to 10. I've just turned it to 20. I stole that from This is Spinal Tap. But anyways, thiol, T-butyl thiol, that's a common name, is added to natural gas to give it its odor. Now, natural gas, the stuff you cook with and heat with, methane, has no odor. Wait a second, Dr. White. I can smell a gas leak, and it's pretty evident when you do. Well, guess what? It doesn't. And now something you should know and remember, hint, you should know and remember, is a very sad, tragic tale. Back about 1935 in a town in Texas, I don't know, I forgot the name, there was a school built brand new, pretty new, and to save money, right next door was an oil well that produced methane as a byproduct. And back then, oil wells just released it to the air, or better yet, more importantly, they burned it off. Well, the oil well company said to the school, you know, the methane we have, you can use it for your furnace and anything else, and cooking, and we won't charge you. Just take it. And they did. Now, there are two stories how this goes. One story is when they built the building, the pipes coming in for methane, they didn't do a good job and they leaked. And at that time, methane was just CH4, methane, and you're not going to smell anything. And enough got into the building that all it takes, and you can't see it right over there, is a light switch. A light switch, when you go like this, inside a little spark, unless you have explosion-proof light switches or mercury switches, but most of you probably don't. I don't. And that spark will set off the methane, which is quite flammable, and the place blew up. And unfortunately killed about 150 students and teachers and injured hundreds more badly burned students and teachers. The other version is they were having some sort of a fundraiser social in the gymnasium. Right next door was the kitchen, and it was a chili social, and they were cooking chili, and whoever was supposed to watch it decided to go into the party or the fundraiser, and the flame went out underneath the chili pots, and you couldn't smell it. And somebody lit a cigarette or turned on a switch, boom, same thing happened. Either version, unfortunately, a lot of children and teachers died and were badly injured. Well, then the Texas state government decided we need to get a commission together to make things safe so that doesn't happen again, because it was a horrific tragedy. You can go and look on, Google it, or go on Wikipedia. Let's see something real quick. It happened in New London, and you can go and read about this, but I was wrong. Unfortunately, it killed more than 300 students and teachers, and that was in 1937 in London. And that was a horrific tragedy. And you should read about this. It's not pleasant, but it's important to understand. And what the commission that the Texas government empowered came up with was the idea, we're going to put something very stinky in methane, natural gas, that if there's a leak, you can't smell the methane, but you can smell the whatever stinky stuff. And remember, I told you thiols stink. Well, they decided to put in T-butyl thiol. How stinky is T-butyl thiol? They only put 4 pounds of T-butyl thiol in every, are you ready for this? Billion pounds of methane to make it stink like it does. And you can tell real quick if you got a gas leak. And that's how stinky thiols are. That's like 4 parts per billion. And wow, but it's, I'm sure, saved lives. You should know. 1, thiols stink. 2, you should know thiols have been put into natural gas so you can smell a leak and save your life. Oh no, guess what time it is? It's new functional group time. And it's new chapter time, new functional group. Wow, we're moving along. I'd rather be a little ahead than a little behind. And we're going to lose time because of the 4th of July. A whole day would be the same as almost a whole week in a normal semester. All right, before I open it up, what this means is, in the summer, it's fast paced. this Monday, I will go through the alcohol problem set. I highly recommend you do that. Yeah, you just studied for a test, but summer is fast paced, and I do it at a pace that you should succeed, but you got to keep up. So I'm going to go through on Monday the alcohol problem set. All right. And you wouldn't believe what I'll get into in this chapter, and I will. And let's talk about ethers. Ethers are different than alcohols. They're an oxygen, and attached to that oxygen, like an alcohol is in our group, but instead of a hydrogen here, you have another R group, and this is called an ether. Now, for most ethers in our society, we don't use IUPAC names. We use common names. And the way we do common name for an ether, name each R group on the ether as an alkyl group, and then add the word ether at the end. Ooh, see board for examples. I better get to work. So let's write an ether up here. All right, how do you know it's an ether? You look for what's different, what's not carbon, what's not hydrogen. Ooh, an oxygen. And that oxygen, you have carbons here, I'll call that R, and carbons here, R prime. And this is an ether. Now, how do you name this? Well, the common name is you take and name each R group, R and R prime, as the alkyl group it is. Well, if this were alone on something, that's a methyl group. This is an N-propyl group. And because it's an ether at the end, I'll put the word ether. And that's how you do it. Now, let me just show you quickly the IUPAC way. This is common. I will never ask on a test or a final the IUPAC way for ethers. Now, ethers, you find the longest chain of the two R and R prime, and this is 3. You name it as an alkane, propane. And you count this as a substituent. And this RO bond to something is called an alkoxide. Again, switches off now totally. And this one is called methoxide. And then you say, what carbon is this on? And you start to give it the lowest chain. And it's carbon 1. So that'd be 1 methox, not methoxide, it should be alkoxy. I'm sorry. I was thinking of something similar. Alkoxy, and this is methoxy. So that'd be 1 methoxy propane, which is easier, methyl and propyl ether, which is why all chemists use common unless you're writing legal documents like a patent or a contract. Then you use this. Even sometimes I've seen this still. All right. And here's the compound. It's an ether. What would be the common name of that compound? Your turn. Remember, name each R group as the alkyl group it is, and then add the word ether. I try and give everybody time to finish. All right, let's get going. If we look at this, what's different? An oxygen, it's got carbons here, carbons here. This is an ether. And if I look at this R group, it's ethyl. This is an isopropyl. So it would be ethyl isopropyl ether. Or it could have been isopropyl ethyl ether. Either one is correct because it's common names. You don't have rules like alphabetical order. Let's do one more ether because it's something I'd like to talk about. And this is, oh, look, an ether, 2 R groups, and they happen to be the same, but they could be different on an oxygen, and that's an ether. So I'll name each R group. Oh, that's an ethyl. That's an ethyl. There are 2 of them. How do we say 2 in organic chemistry? Di. So this is diethyl ether. Now I have it on a slide, but I'll tell you now, ethers are flammable, dangerously flammable. Why? One, they're heavier than air, so they don't just evaporate away once you have it evaporated, they stay right here. And these are more flammable than gasoline. Ethers are tremendously flammable. Now, what has been one of the uses of ethers? Well, about 1830s, give or take a few years, they found that if a person inhaled the vapor of an ether, it puts them out. In other words, ethers, especially initially diethyl ether, is a great inhalation, meaning inhale, anesthetic, knocks you out, so you can be operated on. And unfortunately, it was heavily used during our American Civil War and later on for a number of years. Now, there's one problem with using diethyl ether. Well, your patient has ether in his lungs from inhaling it to be put out. That means as he's breathing, ether vapors are all around him. That's flammable. So if you had someone with a candle or a lamp, it could set the patient on fire, and the hands of the surgeon could get burned. By the time in the 1900s, when they were cauterizing wounds with electricity, the same thing happened. Now, what they found was if you replace some of the hydrogens with halogens, it's not that flammable. And let's see if I can find one. Everybody see the structure on the screen? Every intersection right here and here is a carbon. There's a carbon here, 2 here, and this carbon has 3 fluorines. This one has a hydrogen and a chlorine. This carbon on this side has 2 fluorines and a hydrogen. Now, this molecule has a trade name, isoflurane. How they got that? Well, the fluorine in there, probably. Now, when I moved into this house where I'm living in right now, I did a stupid thing. To make things go quicker, I was lifting, once they got moved in my house, heavy boxes like books, each one 150, 60 pounds. I'd pile 2 up, lift it, and I didn't wear a belt for lifting. Guess what happened? Yep, double hernia. And so I had to have a hernia operation to fix that, strengthen it. It wasn't fun. But anyways, I found a great surgeon, and day of the operation is supposed to start at 1 o'clock. I get to the hospital. I think it was Evanston Hospital. One of the places he did his surgery. And you know how they tell you, if maybe you don't know, you put on the gown, they put you on a gurney and wheel you out to the operating room. Well, he wasn't there. And I can see a big clock on the wall and said 1 o'clock, and I'm laying on this gurney outside the operating room. I'm looking like, what's going on? And this very nice anesthesiologist came over, very nice. He's already gowned up with mask and gloves and everything. I think he had his gloves on, I think so. Anyways, he said, I see you're looking around. You don't know about your surgeon. I wonder, what is about my surgeon? I don't know. He said, he's never on time. He's great, but he's never, ever on time. So to kill time, the anesthesiologist, who was very nice to me, said, what do you do? Because I'm your anesthesiologist. And I said, well, I'm an organic chemist. He said, oh, and he brings over the bottle and said, this is your inhalation anesthetic. And that was isoflurane. And we're talking a minute or two later, and I'm saying, I can show you the structure. He said, oh, no, I got to get to work. And I said, what? Can't you tell? Your surgeon's here. No, they had all masks and everything. In case you were wondering, I survived. I'm still alive. But I had really did some damage lifting heavy stuff that I was on the operating table for almost 5 hours for him to really repair it. But he did a really good job. That was, wow, almost 24 years ago. No problems. I'm also careful now when I lift heavy things not to overdo it. So ethers play an important role in our society. Now, I showed you how to do IUPAC nomenclature. This will never be on a test. And I just showed you why we normally don't use it. Now, switch is still off. Ethers have very low boiling point. Diethyl ether, the heat from your hands will cause it to boil. And they're flammable. That's an understatement. Now, do I have time? I do. When I was an undergrad at IIT, a long time ago, taking organic, we used to use ether and other flammable things, and to heat things up instead of a hot plate, surprised we didn't all die from it, we used Bunsen burners. And how do we light it? Not with the striker, with a match. And there was a trough in the middle of our benches where water will go out if you're using an aspirator or condenser, and people would throw their matches in there, which you shouldn't. So there might be ether in there. And we had a lot of fires. I never did because I knew better. But an ether fire, and I've seen a couple, here's the bench top, the vapors stay right here. And somebody over here lights a match and their ether vapors, it just shoots like that, like a dangerously bad. We had this very nice but tiny Oriental grad student who ran our lab. And back then they had the old fire extinguishers that were like 60 pounds, and he couldn't pick it up. It was like about 3 feet high. He could drag it real quick though, but ethers are dangerous. Now, how do you make an ether? You use what's called the Williamson ether synthesis. Switches on full blast. And what's the Williamson ether synthesis? Well, it's named after Dr. Williamson. It's where you take, this is called an alkoxide. I got ahead of myself. And an alkyl halide, where X, as you know, for this reaction is chlorine. Oops, let me do a better chlorine. Chlorine, that's nicer. Bromine or iodine. And here, the alkoxide, this minus charge oxygen, attacks the carbon in R prime with the halogen. And it leaves and you form an oxygen carbon double bond, this sodium and this halogen leaves as an anion, and it forms a salt. So this is the Williamson ether synthesis. And the carbon in R prime with the halogen is the carbon in R prime bond to oxygen. So let's do some examples. And if you look at the following, what is the organic product or products? Well, if we look at this, what's different? Ooh, oxygen minus charged sodium cation with carbons, alkoxide. And later in one of the labs, I'll show you how we make this, but not now. And then carbon, halogen, that's an alkyl halide. And X can be chlorine, bromine, or iodine. And this attacks that, you know, organic chemists are violent. We use the term, actually, if I were with other colleagues, well, that attacks that. And it kicks this out, you lose this, and you make an ether. And if I wrote, give the organic product or products, you don't have to put the salt because that's inorganic. Well, if we look here, what's R? What's R prime? 3 carbons. Now, this oxygen bonds to the carbon, this one, the end one that had the halogen. So what do we get? I have 3 carbons here. You're not going to break carbon-carbon single bonds. I have 3 carbons there. And that's what you get. An ether. In this case would be methyl and propyl ether. And it's your turn. What would be the product or products for the following reaction? And for all of you who normally don't make it to class, thank you for coming to class. I've always considered, but I never have, getting game show music to play while everybody's figuring out their answers. You know, like in The Price is Right, which I haven't watched in decades. I think I launched a poll a little early. Take your time. All right, I think everybody's done. Anybody not done? Do you need more time? Give me a thumbs up if you do. I guess not. So let's go ahead and do this. Well, how do you determine what's the product or product? You look here and say what's different, what's not carbon, what's not hydrogen. Well, oh, an oxygen minus and sodium cation. That's what this plus means on carbons, alkoxide. Then here, carbon, oh, halogen on a carbon. Remember, X can be chlorine, bromine, or iodine. And when you react that, what do you get? You get an ether. And you don't have to put this down, but I'll just show you a salt. And the carbon with the halogen is the carbon that this oxygen will be bonded to. So here we have our R group. Here we have our R prime. Which carbon has the halogen? The center one. So I'm going to have my R group ethyl, oxygen. Then notice this is an isopropyl. The center carbon had the halogen. That's the one balanced to the oxygen or bonded to it. And that's how you do it. Oh, let's have some real fun with this. On test 2, I'll have a couple synthesis. It's your turn to try it, and then I'll do it. What two things would you react together to make those two compounds? Your turn. We might go a couple minutes over past our break, but I'll still give you the time. You know I don't cheat you. All right, let's do this. Let's look at this. How do we determine what two things do we react to make this plus this? Well, what is this? What's different? Oh, an oxygen with carbons here and here. And I'll call this R prime and R. And we have here sodium and the halogen NaX. And what do we make? This is an ether. We take an alkoxide plus an alkyl halide. And I can say this is R and this is R prime. And if I do that, R is methyl. So I'll have methyl oxygen with a minus charge, sodium cation. R prime right here is ethyl. And what's the halogen here? Well, I gave that, that's why I gave the salt chlorine, and you get that. If you react that with that, you'll get that ether. However, and this is something that's sometimes common in organic chemistry. What if I call this group R prime? And I can call this group R. Well, if that's the case, the alkoxide is this. And this alkyl halide is this. And guess what? You're going to make the same molecule. And the question is, which one's right? And the answer for my class is they both are. Now, in the real world, mine, there's something called cost accounting. And probably the one regret I did after I got into industry that I should have done in undergrad or grad school, and that was take an accounting class. Because when I became a senior manager, I would go into meetings with the president or CEO of the company, other senior managers, and a lot of it would be talking about profits and losses and accounting. And I didn't know what was going on. I never took accounting. What's gross margin? What's EBITDA? And all things like that. And my boss pulled me over and said, "You don't know accounting, do you?" No. He said, "Find a book and learn it." And luckily, my accountant had a good, accounting 101 book for industry, and I learned it. Well, if you look at the reaction right here, I know prices of chemicals and cost accounting, and this route is cheaper than this one. So this is the way I would go to save money. And this I can get cheaper than this and this. I'm probably the one and only other than one other, I think, chemist at ECC, at COD. I don't even think anybody else but myself knows chemical, cost accounting like I do. But if I look at the clock, let's take a little longer break because I ran you long. Come back at, it's not longer, 3:55, and we'll start the lab, and I'll let you out a little early so you can get started on the test if you want to. So I'll see you in 5 minutes, 3:55. All right, let's get going. And by the way, after today, you've survived 2 whole weeks of organic chemistry with me, Dr. White. That's a good thing. Hopefully you're doing well. All right, today's lab deals with something interesting, and that's aromatic compounds. And the only sad thing is we're not doing this in the lab because it's fun, but some of this you can try at home. And that is using your nose. Aromatic compounds are called aromatic compounds because they have a very strong aroma, smell. Now let me just close something here. All right, thumbs up, people. Everybody see Aromatic Compounds Lab on your screen. Now, aromatic compounds, as I mentioned in the lecture, through the 1400s to 1700s, there are many wars through European countries to control spices and the land where spices were grown. And huge fortunes were made because of the sale of spices. And these spices and plants have a common feature. They contain aromatic benzene ring. That's why they're called aromatic compounds. And some of these compounds can find in spices. Now, the compounds, eugenol, isoeugenol, vanillin, benzaldehyde, and trans-cinnamaldehyde. Now, in this lab, if we were face-to-face, and if you have some of these things I'll talk about at home, I'd ask you to smell that. Now, your nose is an extremely sensitive analytical instrument. In other words, you can identify things you can smell. And if we were in the lab today, we'd be all around this one bench, and I have some stuff out that I'll pass around for you to smell. Now, let's assume this is a bottle. It's not, but pretend it is. You never go like that and smell something from a bottle. That can put you on your back. This is the proper way to smell something. Remember, that's a pretend bottle. Or I guess, well, water bottle isn't gonna, but you do the same thing. And I would pass things around. So let's look at today's lab. Now here, if they were solid or liquid, you'd put a small amount on a weighing paper and smell it. Or if it's a liquid, you'd pour it a little liquid. Now, the things we would be smelling would be cloves, cinnamon, nutmeg, vanillin, as in vanilla extract. Vanillin is a white powder. You buy it dissolved in water and alcohol. And benzaldehyde, which is a liquid at room temperature. Now, I'm going to let you think about and put in your own things. Now, in the lab, I would help you out, and we'd be passing this around. And cloves, I helped you out. A lot of students say, oh, that reminds me of Christmas ham. And I would say, and I told the class, that reminds me of a dentist's office. Dentist's office, well, it turns out, I don't think sorry, let me back up again. You'll be looking at cloves, cinnamon, nutmeg, vanillin, and benzaldehyde. And this table, if you have a chance, if you don't have any, don't have to fill it out, but have some fun. This is organic chemistry, it should. Now, cloves, in the past, students have said, oh, that reminds me of Christmas ham, because some people put cloves in the ham. You ever see the crisscross cuts on top of a ham? And also for Easter, if you have an Easter ham. Now, I told the students it reminds me of a dentist's office. What? Well, let's talk about this. Unfortunately, because of hereditary reasons, it runs in my family. I and my sisters who inherited from my mother, who inherited from, anyways, having dental problems. If you ever have to, I'm sorry I have to say this, get an injection for an anesthetic when they do some work. If you have a good dentist, they'll put something on the skin before they inject you to anesthetize it so it doesn't hurt. And what do they use? Oil of cloves. And if you go into certain dentist's office, it smells like cloves because they're using oil of cloves. And if you go into certain, I forgot what products they sell over the counter to help if you have some tooth pain or gum pain, essentially you're buying oil of cloves. And cinnamon, I think you can all remember what it smells like. If you have nutmeg, vanilla, like in vanilla extract. Now let's talk about benzaldehyde. Now benzaldehyde, this is, I'll teach you later, is the common and IUPAC name for a chemical. And where do you find it? If you smell maraschino cherries or cherries, red cherries, like in Dr. Pepper, or if you smell almonds, like an almond mascarpone, which is an almond paste used in sweets a lot in Europe, which I've been there a lot, you smell benzaldehyde. And it's interesting, in the lab, I pass around some benzaldehyde and paper towels. We do this as a group, this one. And I say, what does it smell like? And some say cherries, some say almonds. I can smell it. I can say, I smell the cherries, Dr. Pepper, if you like Dr. Pepper, which I do. At the same time, I can smell it, close my eyes and say, oh, I smell the almonds. And both cherries and almonds, one of the important components that affects the smell is benzaldehyde. Now, this is a lab, that's a quick lab, but it's a fun lab. Now, here's some questions. Now, the first question is there a common chemical characteristic of all the spices and chemicals that you tested in this lab? And down here, I asked you to draw the structures. Right here. Now, I gave you a hint. Remember the name of this lab. Read the hint. Now, when I ask you to draw this key chemical compound, aromatic compound in each of these, I help you out. Enclosed, the name of that is eugenol. Use Google. And in cinnamon, oh, look, trans-cinnamon-aldehyde. By the way, I love cinnamon. Cinnamon toast. If you ever had good apple pie filling, they use cinnamon with sugar with the apples. I love apple pie. And nutmeg has a similar but different one from cloves. It's called isoeugenol. Now, vanilla extract has the chemical vanillin, and benzaldehyde, look it up. Now, watch closely. At the very bottom of page 4, there's a question hidden there. Students forget to answer that. Don't forget to answer it. I'll take off a point. What's your favorite spice or aromatic chemical? And with that, I'm done. I'm going to let you get ready because in about 5-10 minutes, I will send out an email with the password for today's test. Oh, by the way, this morning I checked it just to make sure it never hurts, and it worked. Well, how do I check it? I downloaded, opened it up on D2L using the password. So with that, remember, don't forget the hand in the lab that's due today or tomorrow, or I'll even give you till Saturday because of the test. Those 2 people who didn't hand in the lab that was due Monday, get it in, please. You don't want to lose 11 points. And finally, I'll say have a nice rest, or Monday, don't forget, I almost forgot. Don't forget, I will go through the alcohol's problem set, and we'll continue on with ethers, and the next part of ethers called epoxides. And you won't believe what I get into. Oh, do I get into some interesting stuff. You'll love it. With that, gang gesund. Bye now. Get ready in about 5 or 6 minutes. I'll email you the